So welcome to this class on t-test. This is a continuation of inferential statistics. So we will introduce the one sample t-test. Here we make an assumption about a population parameter and call it the null hypothesis, denoted by H0. We define another hypothesis called the alternate hypothesis, which is the opposite of the null hypothesis, and this we denote by HA. So a type 1 error arises when a null hypothesis is rejected when it is true, and the probability of making a type 1 error is called the level of significance of the test, denoted by alpha. Now what is a type 2 error? Type 2 error occurs when we fail to reject a false null hypothesis, and the probability of making a type 2 error is denoted by beta. Now, a one-sample t-test determines whether the sample mean is different from the hypothesis stating the population mean. So it goes like this: if H0, that is the null hypothesis, is mu equal to x bar, HA can be mu not equal to x bar. So mu is the population mean, x bar is the sample mean. And test statistic for a one-sample t-test is given by t equal to x bar minus mu by s by root n. And S is, we have already done that before, square root of summation xi minus x bar the whole squared by n minus 1, and degree of freedom is n minus 1. So we have the rejection rule for a lower tail test, upper tail test and two-tail test. What is when you have the lower tail test, H0 will be mu greater than or equal to mu naught, HA will be mu less than mu naught. For an upper tail test, H0 will be mu lesser than or equal to mu naught, and the alternate hypothesis, HA, will be mu greater than mu naught. For a two-tail test, H0 is mu equal to mu naught and HA will be mu not equal to mu naught. So the test statistic T is the same for all, lower tail, upper tailed and two-tailed, that is x bar minus mu naught by s by root n. Again, degree of freedom is same in each case. And the critical value for a lower tail test, we reject H0 if mod t greater than or equal to t alpha. For an upper tail test also, we reject H0 if mod t greater than or equal to t alpha. So the rejection rule is same for lower tail and upper tail test. And for a two-tail test, we reject H0 if t less than or equal to minus t alpha by 2, or t greater than or equal to t alpha by 2, or mod t greater than or equal to t alpha by 2. Coming to questions now. A random sample of size 16 has 53 as the mean. The sum of squares of deviation from the mean is 150. Can this sample be regarded as taken from the population having 56 as the mean? Level of significance is 5%. This is a right tail test. So H0 is mu equal to 56 and HA will be mu greater than 56. And x bar is given to be 53, summation xi minus x bar. What is that? The sum of squares of deviation from the mean. So that is 150, n is 16, and s is given by square root of summation xi minus x bar the whole squared by n minus 1. So that will be, this is summation xi minus x bar the whole squared here. So it is root 150 by 15, that will give you 3.16. And t is x bar minus mu by s by root 10, that will be 53 minus 56 by 3.16 by 4, which is minus 3.79, and from the t table, t 15.05 is 1.753, and mod t is greater than that, so we reject H0. So the sample cannot be regarded as taken from the population having 56 as the mean, because what is H0? Mu equal to 56. Coming to the next question, certain medicines are packed by a machine A. A random sample of 10 bags were drawn and their contents were found to weigh in kg as follows. Test if the average packing can be taken as 50 kg. We are given that T 9.05 using the table is 1.833. So x bar is 49, you can calculate, and s is square root of summation xi minus x bar the whole squared by n minus 1. When you calculate, you get it as 7.03. So let H0 be the null hypothesis, that mu equal to 50. HA will be mu greater than 50. Again, what is T? X bar minus mu by s by root 10, that is 49, minus mu is 50 by 7.03 by 3, this will give you minus 0.426, and mod t is less than t alpha, so we accept H naught. So what we accept the fact that the contents are average packing can be taken as 50 kg. Let's move to the next question. The mean weekly sales of candy in stores was 146.3 per store. After a campaign, the mean weekly sales in 22 stores for a week increased to 153.7 and showed a standard deviation of 17.2. Was the campaign successful? Level of significant confidence is 5%, and you are given that T 21.05 using the T table is 1.721. So H naught will be mu equal to 146.3, HA will be mu greater than 146.3. You are given that S is 17.2 and X bar is 153.7 and N is 22. So T is X bar minus mu by S by root 10, that is 153.7 minus 146.3 by 17.2 by root 22, which is 2.01, and T is greater than T alpha. So we reject H naught. That means the campaign was successful. That is mu is greater than 146.3. Let's do one more question. No, so we'll stop here, and the next session on inferential statistics will continue more problems on the t-test. So we have learned the basics of the t-test and how to apply them to problems. Thank you.